Greetings! We begin with the sad news of the passing of one of the true greats of science and astronomy. Frank Drake, a pioneer in the search for extraterrestrial intelligence, a partner with Carl Sagan in the design of the Pioneer plaque, and developer of the famous SETI equation that bears his name, and so much more, died at the age of 92 in California. His talented daughter, Dr. Nadia Drake, tweeted the news. Her Twitter feed is filled with a who's who of astronomy and space figures expressing their condolences and remembering his intense curiosity and love of science. There is yet another death to report. Astronaut Don Lind, payload commander of STS-51B in 1985 aboard Challenger, passed away on August the 30th, also at the age of 92. Lind was selected in 1966 and would have flown on the Skylab rescue mission that was never needed. Turning to the Artemis countdown, early preparations are on track for the Saturday launch attempt at 2:17 p.m. Eastern. The weather should be acceptable, especially toward the end of the 2-hour window. Here are some comments from Friday's briefing.
So we do a series of checks throughout launch countdown and actually in between the last attempt and this one where we go through, we do thorough inspections of the vehicle. Even very minor defects are noted. Throughout launch countdown, we have a team which we call Sea Ice on the console, and they do inspections throughout. So they use high-definition cameras, infrared, things along those lines. And so right now we've done a full inspection of the vehicle. We've noted any nonconformances, and they've cleared any of those for flight. Throughout the count, as we see cryopumping, things like that, we're going to continue to do the same thing. If anything is anomalous, they note it, and then they turn it over to a debris trajectory analysis team to decide whether or not we have any concerns. So they have standards that they use against, and they have models that we run it if it's above those standards. There's not a lot of margin in the timeline. It's very orchestrated, but they may be able to deal with certain, 15-minute delays, 20-minute delays, those sorts of things, and we'll try and make up time as they go through. But I would just say there's not a lot of margin in that timeline.
So our weather is going to start off at a 40% probability of violation, which of course means a 60% go. However, we do start evaluating the weather 3 hours before the launch window opens. So of course, that's right around 11 o'clock or so. So I do expect to make some no-go calls at some point tomorrow. However, as that East Coast sea breeze drifts farther inland, we do expect clearing on the back side of that. And that is because that is the reason why we are trending the forecast to more of an 80% favorability at the end of the launch window tomorrow afternoon. So now we can go ahead and flip to the backup forecast, and that is on Monday afternoon and evening time frame. I have the same numbers that I gave you yesterday, basically a 70% probability of go. However, there's a little bit more uncertainty in this forecast than what we had before. Previously, it did seem like we'd have a pretty steady easterly flow. At this point in time, it does seem like we're going to have a ridge right on top of us in the mid-level layers of the atmosphere. And because of that, it's kind of splicing the flow a little bit more than we expected. To the north of us, we're expecting more on the side of westerly flow, and to the south of us, we're expecting easterly flow. So of course, we're smack dab in the middle there, and that gives us a very, very light flow regime, and it could almost go either way. So with a forecast like that, basically we're going to be focused on the weather with those inland sea breeze boundaries. And sometimes with that kind of situation, we can see some anvils floating back towards us in general in the late afternoon and evening timeframes. So because of that, I did go ahead and add the anvil rule into the backup launch window. But in any case, like I said yesterday, I do not expect weather to be a showstopper by any means for either launch window.
The Thursday evening presser provided a comprehensive story about the data analysis that convinces SLS engineers proper thermal conditioning of the engines did occur during the aborted Monday count, despite warmer than expected sensor readings. This detailed explanation provides confidence in the rationale for ignoring the sensors which were not part of the operational red line system. No launch commit criteria constraints for engine start will be waived or any sensors masked. The full rationale now allays any concerns that exceptional risks are being taken with the engines. Artemis mission manager Mike Sarafin discussed a previously unknown concern regarding the intertank flange foam insulation crack. He said there is a very small chance that a chunk of foam could be liberated during launch and strike a solid rocket booster separation motor. It seems ironic that decades after foam insulation on the shuttle's fuel tank was a life-or-death issue, a rather similar problem has reappeared. Unlike the shuttle, the crew module position above the tank prevents damage to the Orion capsule, but remote risk to the critical solid rocket booster components still exist. Perhaps more analysis of this persistent foam risk could point to further remediation measures prior to the crewed Artemis II mission. Here are the highlights from that briefing.
And so we had some sensors that didn't tell us what we thought we would do, and we did the right thing by standing down with that uncertainty on Monday. But we have confirmed that we did have good flow through those engines. We know we can chill those engines. We're ready to proceed that way to launch.
The bad sensor, would you just ignore it?
Yes, we will.
Certainly, we have nearly 500 launch commit criteria and 489 launch 489 launch commit criteria, any one of which affects our overall risk posture headed into the launch attempt. So this was one particular situation that coming out the engine thermal conditioning was one particular and very unique situation that we carried out of the agency flight readiness review as a known first-time demonstration in the launch countdown. Unlike the other launch commit criteria, we just knew that this was something that we had to do successfully for the first time.
This sensor was never intended to be used as an LCC or for this purpose. It is not part of ALS. It is not part of the startup protection. Ultimately, the reason we use this sensor is to get an initial indication of cold fluid. We did combine this launch attempt 1 with an objective we did not achieve in wet dress, and that's why we had more verification work to do. We were going to do that verification early in launch attempt 1. This sensor failure prevented that verification, and that's why we had to go to subsequent measurements. And we were able to achieve that really only because we were in these conditions for a long time with fully tanked and flow through the engines. If we wouldn't have done that, we wouldn't be able to verify all that we could to verify that it was liquid and that it was a bad sensor.
We have convinced ourselves without a shadow of a doubt that we have good quality liquid hydrogen going through the engines, and there's no fuzz on that. We've also, through the course of analyzing the data, looked at 5 additional measurements that we can look at to assure ourselves that we are getting that quality data, and that's on the engine. That's on the engine side, and then on the core stage side, we were able to go back and verify that the core stage is providing the amount of hydrogen and the quality of hydrogen to all 4 engines.
There was some incremental risk acceptance. As the mission management team, it is our role to review risk acceptance and then the flight readiness rationale. And then we also have requirements change authority following the agency flight readiness review, and we review any changes from the previously accepted risk baseline that we had at the agency FRR. And we did that today. Only 2 of those items required some incremental risk acceptance, and that was the thermal conditioning of the engines associated with the engine bleed, and then the core stage thermal protection system, the crack that we saw, specifically what is termed crack number 2 at the intertank flange, just due to the potential for debris transport. and then contact with the booster set motor. It's a low likelihood occurrence, but it is something that we considered an acceptable risk.
During ranges of temperature, it gave us the right slopes. It seemed to work fine, and then it did not give us an indication that we expected at the very cold temperature. So it really was an interesting signal, and that's part of the pause. It didn't just fail off scale or anything. So, but John is right. It is conclusive that that sensor was not a witness for what we were looking for. It's absolutely true. On the engine side, we do have advanced health monitoring. The reason we chill the engines for numerous reasons, but the primary one is for the high-pressure turbopump bearing. And that high-pressure turbopump bearing doesn't have to be all the way as cold as the liquid, but it's got to be cold. And if we know the liquid is going through, then we know it's about that temperature, and that gives us margin to that problem. And if it starts up and it's not cold, then it can skid. Ultimately, that causes excess wear on startup. That would manifest potentially as a shutdown during flight. It would be a red line. It wouldn't be, I'm not sure how you characterized it, but it wouldn't be an uncontained failure generally.
So the ICE team is a really important part of my launch team, just like they were back in Space Shuttle. And one of the things that they do today, just like they did back then, is they provide an L-1 hour report on all of their findings. One of the differences is that they utilize high-res cameras out at the pad, and we've specifically placed additional cameras so that they have multiple views, and they can look at that without having to be deployed to the pad. So we've allowed technology to assist them in doing their job, but the report in terms of the kinds of things that they're looking for, the report that they make is very similar to what they did with Shuttle. It's just that they're doing it remotely. And we also have the capability, should we ever need to, if we had something where we felt like we needed to send them to the pad, we certainly have the capability to do that. We could send them in as a red crew to go evaluate something very specific. But what we have found is that the imagery that we get back in the control center has been more than adequate to evaluate all the different areas and the performance of the core stage.
And so that's buried inside of part of the engine. And so we count on a certain amount of mass flow for a certain amount of time in order to ensure that that bearing is cold. We did that during Shuttle. We've done that during the entire program that used formerly the Space Shuttle main engines and now the RS-25s. And so that verification is a process verification we just didn't achieve in WDR4. That's why we were using this measurement. It's not part of ALS, so there's no masking in the computer software. All the normal protections are in place. We added an LCC. I asked Charlie to add an LCC for this verification because we didn't receive it in WDR4. That's ultimately what this measurement is. It was never really intended for the purpose we ended up using it for.
We don't have an updated number. What I would say is there was no appreciable increase in risk. There was a delta risk acceptance because we know we have a crack in the foam. We have a nonconformance at the intertank flange area. We know its location. We know the approximate size, and there's a small likelihood that it could be liberated during launch, follow a very specific trajectory, and hit one specific location on a booster that could cause a problem. The likelihood of that is very low. In addition to that, as we talked with the engine bleed, the thermal conditioning, it really comes down to the fact that we haven't demonstrated it previously. We have a high confidence that we can get through this, given the indications that Dr. Blevins and John Honeycutt talked earlier. The team has more insight given where we are. We've trained it. We have a more robust plan than we had going into the launch attempt on the 29th. In terms of what that means to 1 in 125, does it change that number? Probably if you go way out in terms of decimal points, but there's no appreciable increase in risk. But we do talk about those types of things to ensure that we understand exactly what we're getting ourselves into before we commit the vehicle to flight.
If there were astronauts flying on board this mission, would you still be launching based on the parameters that you're looking at, or are the risk analysis that you're considering different than if you were, launching the Artemis 2 mission?
Yeah, Michael, that's not an easy question to answer because again, Artemis 1 is the first test flight in a series of increasingly complex missions, and the next mission is intentionally, Artemis 2 is intentionally our crewed flight test. So Artemis 1, we are buying down the risk associated with crewed flight on the next mission, specifically reentry of the vehicle at lunar reentry conditions. In order to get there, we have to set up those initial conditions using the performance of the rocket by getting it to the lunar reentry conditions. The rocket has to deliver us to the point of translunar injection. We want to shake down the spacecraft through flying out through the Van Allen radiation belts, the orbital debris field, and operate it in the deep space environment. Those are all things that we have to do with crew on board on the very next mission. And we know that there's risk involved with this first mission, but in terms of the incremental risks that we dispositioned today at the mission management team, it was a marginal increase in risk, and we are clearly ready to fly on Saturday with an understanding of what that risk is. We would have a very similar discussion on Artemis 2 if we had any of the conditions that we're seeing on this flight, and we would make an appropriate decision. So it's a hard question to answer because it presumes that we are successful on Artemis 1, and there's a non-zero chance that we will find something on Artemis 1 that will cause us to reassess our risk posture on a crewed flight.
Two cosmonauts successfully completed a 7-hour and 47-minute spacewalk on Friday. The EVA was the fifth Russian excursion focused on the preparation of the nearly 40-foot European robotic arm, which was launched in July 2021 with Russia's laboratory module. Software problems delayed early work on the arm, and the last spacewalk on August 17 was cut short by battery problems. Here are extensive highlights of the spacewalk as shown on NASA television.
Do I need to untangle this?
I'll just get over here and be ready, okay?
Камеры, как установлена платформа с адаптерами. Хорошо.
Using the tethers.
Наконец появилась картинка с ваших.
Now we finally get a picture with you.
Ну тогда вот смотри.
Okay, now take a look.
Не, я смотрю, но надо для истории заснять, пожалуйста.
But for the history, for the record, we want to have pictures.
Я пока фал. Или ты мне устал?
Okay, I'll work with the tether at this time.
Какой интересный файл мы наблюдаем на крылокбеге.
That's an interesting.
Да, у тебя сейчас будет минутка, можешь включить свою?
They are about 5 minutes ahead of their current timeline.
Let's adjust this. That's great.
У Ирины, которая у нас
географию преподает. So, that's a birthday, Irina's birthday. She is a geography teacher.
Ребят, если вы передохнули,
okay, if you rested enough,
тогда выключаем камеру.
Let's turn off the camera. And translate further.
Выключаем камеры.
We are turning off the cameras.
Да, подольше там. 2-3 секунды. Оно должно...
Just 2-3 seconds and it will turn off.
Сигнал подать.
There should be a signal. Okay. It's not blinking anymore.
Ага. Все, у меня тоже не мигает.
Okay, mine is not blinking either.
Вы
во время съемок СМ снизу снимали? У нас через 5 минут день начнется, так что мы успели вовремя заснять.
So in 5 minutes it will be dark. So.
То есть я всего сделал 2 действия.
So I have executed 2 steps.
Да, правильно.
We're currently seeing helmet cam views from Artemis suit.
And then power. Okay, it is deactivated now, and LED is not illuminated. Okay, go ahead and cover it.
His task will be to remove the European robotic arm from hibernation mode and turn it off.
Okay, cover installed, and now installing the outer cover.
Copy. Step 12, press start on start-stop. Complete. Prompting to start-stop. Should I start-stop? Stand by.
Working with MCCM, that's Mission Control Moscow, Oleg Artemiev EV1 is powering up the control panel.
Elapsed time 1:52. We are ahead by about 30 minutes.
Okay, it's installed. So 19 revolutions counterclockwise. 1, 2, 3, 4. So this one is in firm position. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19.
If you're just joining us, we are 4 hours and 55 minutes into today's Russian Spacewalk 45A. You're currently seeing Oleg Artemiev and Denis Matveyev of Roscosmos. Artemiev is wearing the Orlan suit with the red stripes, while Denis Matveyev is wearing the Orlan suit with the blue stripes. They are currently tying down a bundle of launch restraints and MLI, or multi-layered insulation, that they retrieved earlier today. They're tying it down to the end of one of the Straya booms.
Go there. Okay, let's try this. Okay, this ring is secure. Okay. Okay. You're a little bit in the way. All right, let me grab the short one. So I can attach this one. Yes, right here, and I am moving away. Okay, it seems to be going pretty well. I think it's clearing all the structure. Can you turn your camera on maybe? So, and keep it on? You can set it on your chest. Okay. Okay. Going nicely. I think it cleared by 50 centimeters. You said 50? Yes, 50 centimeters is okay. All right. Oleg, Denise, how are you copying? Loud and clear. I had to get in another headset because I thought the issue was my headset. Comm was so bad. Did it work? Well, you heard me, right? When was it last time we worked with Strela? Well, right now we are doing 54A, EVA 54A. And last time the Strela was operated was on EVA 45A, so reverse order of digits, about 4 years ago. I understand. It's just that it is tight for a while, and then it goes real easy. It is possible that some wires have frozen. Okay. Watch out with legs. Yes, I'm trying to get under this one. Is this going to be enough for you to reach? Yes. And now extend, right? Yes. Okay, we'll ask Artem. We'll let Artem know when he is on the loop.
Expedition 67 Commander Oleg Artemiev and Flight Engineer Denis Matveyev are currently working on get-ahead tasks where they will extend the Straya Boom 2 from the Zarya module to the Poisk module. The duo has completed the primary objectives of the day, which included the relocation of external control panels for the European robotic arm, as well as a test that tested the rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads.
What am I looking for? I don't understand the word you're saying.
Над дальним концом солнечной батареи. Там мы наблюдаем через телекамеру некий объект.
So there is at the end of the solar array, it looks like there is an object. It's like a little square, right? Or is it antenna you're looking at? No, it looks like a free flyer.
If you're just joining us, we're 7 hours and 16 minutes into today's Russian Spacewalk 54A. Oleg Artemiev and Denis Matveyev have completed all primary tasks and just completed one get-ahead task. Primary objectives that were completed today was the relocation of an external control panel for the European robotic arm, moving it from one operating area to another. They also tested a rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads. The get-ahead task that the duo was able to complete was the extension of the Straya Boom 2 from the Zarya module to the Poisk module. The crew just finished tying up the bundle of protective coverings and the LFM ring, or the launch fixture mechanism ring, that they removed earlier. They tied it to the Straya Boom 1, and the crew is now heading back towards the hatch.
Move inside first. There you go. I guess it's fine now. And you can check my spacesuit now. Okay, well, what can I say? Not too bad. Should I move up? Okay. Okay, that's great. And we forgot about the second retainer. Well, I guess we were told not to swap it. Yes, we aren't going to do that. And tie it down on the handrail. Okay, copy. Tie it down.
Да, то есть сначала делаем узелок вокруг поручня, а потом...
Yes, make sure that you make a knot first near the handrail.
We currently have live views as Oleg Artemiev has re-entered the hatch, or the airlock, and we are waiting for Denis Matveyev to ingress as well. And currently we see Oleg Artemiev helping Denis Matveyev back inside the hatch, moving him inside the airlock.
right? Yes. Proceed with the removal of protective rings. And in Moscow, it's already September 3rd, by the way. Already? Who would have guessed?
As we just wrapped Russian EVA, or Russian Spacewalk 54A, with an elapsed time of 7 hours and 47 minutes. The hatch closed on the POIS module at 4:12 p.m. Central Time, 5:12 p.m. Eastern Time. Expedition 67 Commander Oleg Artemiev and Flight Engineer Denis Matveyev completed all primary objectives of the spacewalk, and they also completed one get-ahead task. The duo was able to install a platform with adapters on the Naoko module. They also transferred the control panel for the external control panel for the European robotic arm and connected it to the base point of the Naoko module. They also installed 2 gap spanners. They overrid 2 end effectors, end effector 1 and end effector 2. They also tested the grappling mechanism on the end of the European robotic arm, and they installed the Straya Boom 1 retainer. The get-ahead task that they completed was the Straya 2 extension from the Zarya module to the POIS module.
Following up on the Webb Space Telescope exoplanet news from yesterday, tweets from astronomer Hugh Osborne ponder the fact that Webb will produce new exoplanet data roughly every week from transit observations, plus directly imaged substellar objects. He calls it revolutionary. This plot from Dr. Nicole Colon, planet hunter at Goddard, shows the wide range of Cycle 1 observations that includes hot Jupiters, lava worlds, and even some potentially temperate Earth-like worlds. So much knowledge and discovery awaits. Upcoming launches include the New Shepard NS-23 suborbital science jaunt, which has been stuck on the ground in West Texas because of uncooperative weather. Falcon 9 resumes the build-out of this Starlink mega-constellation on Sunday, with launch from Pad 40 at Cape Canaveral Space Force Station, planned for 8:32 p.m. Eastern. Ariane 5's 114th mission, with a Eutelsat communications satellite, is slated for Tuesday the 6th at 5:45 p.m. Eastern. For your Saturday, we note that it is World Beard Day. If you have one, like Deputy Exploration Ground Systems Manager Jeremy Parsons, it's time to rejoice. And that's the way space is today. Until tomorrow, ad in Explorata, toward the unknown in the measureless arena of space. Stay tough and competent, and thanks for watching.
Another down day on Wall Street, with the Nasdaq index down about 1.5%. 7 of our watch list companies were up, led by Oceaneering International and Virgin Orbit. Dropping more than 4% were Black Sky Technology and AST Space Mobile. Reporting from cyberspace, this is correspondent Karen Calvis.